Hello. My name is Humphrey Solomon Jr. Welcome to my channel. Our today's video presentation is about case 1 of partial fraction decomposition. I will also discuss very helpful tips on how to use Casio Classwiz calculator to help us solve for the partial fractions faster. Before we continue, please watch my other tutorials about math lessons, and please subscribe to my channel. Thank you so much. You have now had considerable experience combining two or more rational expressions into a single rational expression. Such as this example. 3 over, the quantity x minus 1, minus 2 over, the quantity x plus 5. Using LCD, the least common denominator, we can have this combined in a single rational expression. We will use the product of the denominators as our LCD. And then, simplify our numerator, 3 times the quantity x plus 5, minus 2 times the quantity x minus 1. We can distribute 3 and negative 2, to get 3x, plus 15, minus 2x, plus 2. After that, we can combine like terms, to get our final answer, the quantity x plus 17, over, the product of the quantity x minus 1, times the quantity x plus 5. Frequently in more advanced courses, particularly in calculus, it is useful to be able to reverse this process, that is, to be able to express a rational expression as the sum of two or more simpler rational expressions called partial fractions. As is often the case with reverse processes, the process of decomposing a rational expression into partial fractions is more difficult than combining rational expressions. Basic to this process are the factoring of polynomials and solving a related system of linear equation, where we will use Casio Classwiz, which will surely cut down our solving time. We will confine our attention to rational expressions of the form p of x over d of x, where p of x and d of x are polynomials with real number coefficients. If the degree of p of x is less than that of d of x, then this is called a proper fraction. In addition, we will assume that the degree of p of x is less than the degree of d of x. Like the two rational expressions here. If the degree of p of x is greater than or equal to that of d of x, we have to divide p of x by d of x to obtain q of x plus r of x over d of x. Q of x is the quotient, and r of x is the remainder. Where the degree of r of x is less than that of d of x. For example, this rational expression has a numerator's degree higher than the denominator's degree. So, if we do polynomial division, we can get this. A polynomial with a rational expression. Now, let's discuss a basic theorem. Equal polynomials. Theorem 1 states that two polynomials are equal to each other if, and only if, the coefficients of terms of like degree are equal. For example, the quantity a plus 2b times x plus b is equal to 5x minus 3. If we equate the coefficients of x, we will have an equation, a plus 2b is equal to 5. And then, if we equate the constant terms, we will have b is equal to negative 3. And then, we can substitute b equals negative 3 into the first equation to solve for a. Now, let's start with our example for case number 1. Non-repeating linear factors. We have here the quantity x plus 7 over the quantity x squared plus 2x minus 3. Our first move is to factor the denominator. We will use our Casio Classwiz. Let's put it into equation mode, press the menu key, then we look for the equation mode by pressing the right direction key, down direction key, and down direction key one more time, then the equals key. Next, we select the option 2, polynomial, then, we enter the degree of our polynomial, 2. After that, we will now input the numerical coefficients and constants of the denominator, and then press the equals key. We now have x equals 1, this means x minus 1 is a factor. And x equals negative 3, This also gives us x plus 3 as the other factor. So, our denominator, in factored form is the quantity x minus 1 times the quantity x plus 3. Now that we know the factors of our denominator, we can write a partial fraction for each factor. We will use the variables a and b as the numerators, since we are still in the process of finding the partial fractions and we don't know those values yet. And then, we will combine these partial fractions into a single rational expression. Observe that the rational expression we started with, and the rational expression we got with a and b, have the same denominators. This will allow us to equate the numerator separately. And then, we can simplify the right side by distributing the a and the b. After that, we can rearrange the terms, so that the terms with x can be grouped together, and so as the constant terms. And according to theorem 1 of equal polynomials, we now have a system of linear equations. A plus b equals 1, for the coefficients of x, and 3a minus b equals 7, for the constant terms. We will again use our Casio Classwiz calculator, this time, in solving the system of linear equation, and finding the values of a and b. First, we need to put the calculator into equation mode, and then, we will select option 1, simultaneous equations. And then, we will input 2, because we only have 2 unknowns in our system of linear equation. After that, we will now input the coefficients and constants of the 2 equations. After we input all the coefficients and constants, we will now press the equals key to get the value of x. Notice that the value of x corresponds to the value of a, equals 2. Pressing the equals key again will give us the value of y, which corresponds to the value of b, equals -1. We will now use these values of a and b to write our 2 partial fractions. Please make sure that you don't switch the values of a and b, or else, your answer will be inaccurate. The final answer is 2 over the quantity x minus 1, minus 1 over the quantity x plus 3. I hope this video helped you learn about the case 1 of partial fraction decomposition. You can also watch the other cases of partial fraction decomposition from my channel. Thank you for watching this video. Don't forget to hit the like, share, and subscribe buttons below.